now.
Okay, good afternoon, everyone, and welcome to a special program of the Johnson Space Center chapter of the NASA Alumni League. The NASA Alumni League consists of about 500 retirees. We meet on the first Thursday of every month, where we have a program on some topic dealing with space. Today's first Thursday program will be one of our most interesting. 40 years ago today, NASA was preparing to launch STS-1, the inaugural flight of the Space Shuttle. Space Shuttle Columbia launched on April 12, 1981, with John Young and Bob Crippen on board. Columbia would orbit the Earth for 36 times over its 54-hour duration flight, and then land at Edwards Air Force Base in California. It was the beginning of the Space Shuttle era, an era in which 5 orbiters flew 135 missions. And today we will discuss that first shuttle flight with a panel of 5 of its key participants. I am Stokes McMillan. I will moderate today's discussion. So now let me introduce our distinguished panelists. Bob Crippen. Bob, you might raise your hand. Bob was first selected as an astronaut for an Air Force program, the Manned Orbiting Laboratory. When that program was canceled in 1969, he transitioned over to the NASA astronaut cadre, where his first flight was as pilot for STS-1, flying with Mission Commander John Young. Crippen himself later commanded 3 space shuttle flights. After his last flight, he became director of the shuttle program at NASA headquarters, and then he became director of the Kennedy Space Center from 1992 to 1995. Under Bob's leadership at KSC, 22 space shuttle missions were launched. Richard Truly was also an astronaut for the Manned Orbiting Laboratory program, who transferred to NASA. Prior to STS-1, he flew the Space Shuttle Enterprise with Joe Engle during 3 approach and landing tests at Edwards Air Force Base. Dick was Crippen's backup on STS-1, and then was the pilot on the second shuttle flight, STS-2, again flying with Joe Engle. Dick went on to command STS-8. Eventually, he became NASA's 8th administrator. From 1989 to 1992, he was the first astronaut to lead NASA. He retired from the Navy with the rank of Vice Admiral. And Gene Kranz. Gene was a fighter pilot and a B-52 flight test engineer before joining the Space Task Group in 1960. As NASA's 2nd chief flight director following Chris Kraft, he directed missions of the Gemini and Apollo programs. He was the division chief for flight control during Apollo. Known as White Flight, he was the lead flight director for Apollo 11 and was on console when Neil Armstrong and Buzz Aldrin touched down on the moon in 1969. Gene was also the flight director on shift when Apollo 13's major malfunction occurred. He later served as the chief of the Mission Operations Directorate at JSC from 1983 until his retirement in 1994. Neil Hutchinson joined, Neil, you might raise your hand. Neil joined NASA in 1962. He spent 5 years as a leader of the Gemini and Apollo telemetry system software in Houston's new Mission Control Center before transferring to the Flight Control Division. There, he was a guidance officer and a GNC engineer during early Apollo missions. He was selected as a flight director, Silver Flight, prior to Apollo 16, and continued in that role for Apollo 17, as well as all 3 Skylab missions and the Apollo Soyuz mission. For STS-1, he was the Ascent flight director. He also led the STS-2 Ascent team. He finished his flight operations career as lead flight director for STS-3. And then after a tour at NASA headquarters, he was selected as the first space station program manager, a position he held until retirement from NASA in 1986. And Chuck Lewis began NASA as a remote site Capcom during projects Mercury and Gemini. He spoke to astronauts from such places as Zanzibar in East Africa, and this was during a communist takeover, and the Canary Islands and Australia. He began in the Mission Control Center as an assistant flight director, where he worked the Apollo 5, 9, and 11 missions. He was selected as a flight director in 1972, where, as bronze flight, he supported Apollo 16, 17, and Skylab. During the Apollo Soyuz flight, he led the U.S. flight control team in the Soviet Union Control Center. For STS-1, Chuck was the orbit flight director. He then served as lead flight director on STS-2 and 4. He was also lead on his last flight as a flight director, STS-9, which was the first flight to use the new tracking and data relay satellite, communication satellite, as well as John Young's last flight. And so that's the introduction of the panel. So now let me start asking some questions for our panelists.
Hey, Stokes.
Yes, sir.
May I interrupt a minute? I'd like to recognize two other people that we've lost in these past years. And first is the other half of the STS-1 crew, STS-1 Commander John Young. And then secondly, we had a trio of flight directors. We've lost one of those, Don Putty, who was the entry flight director. They're in our memories today. Thanks.
Thanks for bringing that up. You're right. Okay, first question, Bob Crippen. STS-1 was the first time a manned spacecraft had been flown without a full-up test flight, and it still has that distinction. How did you feel about that at the time?
Well, the Space Shuttle had never been designed to fly unmanned, but I think about a year before the launch, that question was brought up and addressed up through management, my recollection is. And both John and I lobbied that we ought to be on board for the first flight because we thought the chances of success were better if we were on board. Plus, it would have been very expensive to modify the vehicle and it would delay the schedule even more. So I was happy that we launched it with the crew on board.
You know, Stokes, a comment that I would also make, the interesting thing about STS-1 and where we were in the history of spaceflight, we had a lot more tools that we could deal with on the ground, computational fluid dynamics, all the structure testing. And it never really entered my mind until after the fact that we had literally increased the risk by manning it. In fact, as Crippen has just said, my opinion always was we decreased the risk because we could handle so many more issues that might crop up. And I also kind of felt like the amount of work that had gone on, testing engines, testing tiles, and the like, was we just were able to do it more thoroughly before flight than we had been back when we were doing Mercury and Gemini. And so I absolutely agree with Crippen. I think that it was a decision process that had a fair amount of logic behind it and a fair amount of technical merit.
I had what I call the worries list going back. I had two specifically that I was concerned about. One was the asymmetrical shape of the stack on the pad. And I say that because it just seemed like, how in the world, I wasn't a structures guy, how in the world are you going to be able to calculate the loads, the pressures, the pressure gradients, all the things that are going to be so involved right at liftoff in particular in the first few up to clear tower. That really bothered me. I thought, how in the world are they going to do that? I'm a double E. I wasn't the loads guy, so that always was nagged at me a little bit. And then the other one was the lack of a viable crew abort capability early in the flight, early in the ascent. That really, of course, that bothered me for a long time, but that was one I thought about. It was on my worries list. There's a couple others, but I think they've been covered. The shape of that vehicle, you know, that was, before that was all symmetrical. After that was all symmetrical, and we had this thing up there that just didn't look right.
Well, Stokes, I have a different take on all of that. I think that the early shuttle program was, I think, the last hurrah of the people that created the manned spaceflight program, starting with the Space Task Group. It was very heavily endowed with a flight test background. The people had done the work. Walt Williams, Sig Schoberg, Dr. Gilruth, and the early advent of spaceflight. It was endowed with the people that came in from Canada from the Avro Aero program. So you had the learning through the process of their previous experiences in aircraft that then moved into the Mercury program, and we made a lot of mistakes. We made a lot of changes as a result of that. But then we had the Gemini program to basically build the team, prove the technologies, and Apollo to put it all together. I think Skylab was a marvelous enterprise in what I'd say systems engineering, in-flight management, these kinds of things where we learned some of the new skills we needed. But I think as we prepared ourselves and got into the early shuttle program, we had the mature judgment of an entire workforce in addressing risk, responsibility, design modification, changes. And as Neil put it out, we had a vast array of new technology which came in to help us. So I think that this is probably the right time to make that very strong move to an unmanned first launch.
Okay, thank you all. Great comments. Okay, second question is for Admiral Truly. Dick, you and Joe Engel, along with another crew of Fred Hayes and Gordon Fullerton, paved the way for STS-1 by flying the approach and landing tests aboard Space Shuttle Enterprise at Edwards Air Force Base. Could you tell us a little bit about those tests, please?
Sure, Stokes. ALT, the program boss was Deke Slayton. And the flight director was Don Putty. And later, Don was the entry director for STS-1 and 2, and I don't know how long. But ALT flying the Enterprise was supposed to demonstrate that the shuttle could land as an airplane, but it did so much more. It gave Rockwell the experience of building airplane shaped like the Space Shuttle, but it was an airplane. And we flew 8 flights. 3 had a crew in them, and but did not separate from the 747, and then 5 flights that separated in landing. But I think the real value of ALT is it gave us experience. For example, it had 3 hydraulic systems. It had 3 APUs. It had the flight hardware computer systems, several primary systems, and it had backup. And so the flight control organization through Putty and his team got the experience of 8 flights with all that hardware. And even though there was plenty of differences between Enterprise and Columbia, it was very valuable, and for that experience. And I have to mention that the 747 was piloted by Fitz Fulton and co-piloted by Tom McMurtry, and the flight engineer switched off between Vic Horton and Skip Guidry. So we did demonstrate that this airplane could land, but we also got a whole lot of experience with many, not all, but many of the systems that we would have to operate in orbit. And it was a great program, and flying on top of the 747 was a dream for a pilot.
Well, thank you very much. Okay, next question goes to Gene Kranz. Gene, there was a gap of nearly 6 years between the 1975 Apollo-Soyuz test flight and the first shuttle flight in 1981. During that gap, America flew no crewed missions. So how did this affect your cadre of flight controllers?
Stokes, this was probably the same challenge was faced twice. As I indicated earlier, to a great extent, the beginning of the shuttle program provided a challenge and opportunities for many of the people who were in mission operations to move into other jobs. At the conclusion of the Skylab program, moving into the Soyuz, Lunny left, Aldrich left, several people went into other organizations within JSC, which basically was a loss of top-level management. Unfortunately, we had the depth that we could move experienced people to replace them. The real recruiting problem and the challenge we had was the new generation of young controllers. And at that time, we were limited in recruiting because the shuttle program needed the funding. And the old excuse was, well, we'll start providing money for people for operations once we get closer to the mission, to the flying, actual flight. And we set up what was a sort of a prototype boot camp as we brought in young people. For instance, we brought in a large number of young people, I think almost an entire class from Notre Dame at the beginning of the shuttle program. But they were experienced in academics, but they had to become experienced in operations. And we established a technique of setting up with mentors, classes that were very demanding, long days, 12-hour days of work to get them used to the kind of routine we work in mission operations. But by the time we came around to the first mission, Neil's mission, I had basically the entire staff of mission operations. We had 19 of my frontline supervisors sitting in the consoles to provide support for the STS-1 mission. And these were branch chiefs and virtually every branch, every section chief that we had. So the question is, how do we transition into the STS-2 and 3? Because at that time, we were talking about relatively short intervals between the launches. And we were also talking about massive changes from a standpoint of program content. It wasn't like Apollo, go to the moon, go to a different landing site. Now we're introducing the DoD. We brought various customers into this thing, variety of payloads. So this was a challenge that we really weren't on top of until we were about 2 years into the program. And we had the opportunity to train the next generation of young supervisors and leaders. And I could get my supervisors back supervising, running the organization.
I would add to something to what Gene just said about the value of that gap to me personally and to some of those guys who had, even though we had gone through Apollo and Skylab and ASTP, the shuttle was a brand new vehicle. We didn't know squat about it. It had systems on it that we had never messed with before, like APUs, like Dick said, and these marvelous redundant set computer things, which we weren't sure exactly how to work, and a 4-string redundancy system in the avionics. And quite frankly, some of that was evolving as Rockwell began to finalize design things and get software built and so on. But the flight control folks that left the ASTP missions behind had a huge, even the experienced guys, learning curve. And we used that time to build, for example, one of the training tools, in fact, it's one of the most valuable things we ever did in flight control, was the systems guys built drawings of the vehicle systems that were then scrubbed down by Rockwell and us and by E&D. And they're the drawings that basically are used in the control center when you have a problem. And we spent that time doing that. We also, and Crippen and Dick can vouch for this, we started, we didn't think that gap was going to be 6 years when we started. In fact, when we got through with Apollo Soyuz, we thought we had about 3 years to lift off. And we couldn't have anticipated all the problems with engines blowing up and tile falling off, and that would have that delayed us as time went on. So we actually started practicing with the flight crews in a simulator with all the software in the control center and the first or second version of those systems drawings in 1978. And we simmed and we simmed. And of course, in the beginning, the simulator crashed every third time we tried to get somewhere in it. And there were a lot of fits and starts, but we slowly but surely got into a process where our training regimen improved to the point where we were really learning about how this ship flew and about its systems and how they worked and so on and so forth. So I frankly, although in the beginning, I thought, my God, you know, this is going to get really stale if we're going to be 5 years between console jobs. And in the end, it was very, very busy. And thank God we had it, because by the time we got to the real launch, we had practiced everything that known to man. And I felt very comfortable that the systems guys and the trajectory guys and all the other folks involved in this were ready to fly. The other comment I would make to support something Gene said about the people that were on those first teams, I had 6 future flight directors on my Ascent team. 6. 4 of them were in the MOCR and 2 of them in the SSR. And Gene is exactly right in the fact that we basically set the STS-1 framework up with guys who had been there and done that. And even though they had a huge learning curve to get on board with this vehicle, thank goodness we had the time to get on board.
Yeah, Stokes, I'd like to continue a little bit more from a standpoint of where Neil was going. I covered the CCB with Aaron Cohen during the entire development. And Aaron, after seeing some of the controllers, we'd have to go in and justify our requirements right on the line, started developing an enormous amount of confidence within the members of the flight control team. And this actually bootstrapped from the work they were doing in preparation for a mission now to justify and address some of the design changes and the alternatives that were in there, et cetera. In fact, for the mission, we actually had a series of what we called workarounds, recognized deficiencies, changes that should have been made and will eventually be made, but we would accommodate through a series of procedures, modification crew, work on the ground, et cetera. So the workarounds became a element of the CCB process, where we not only reviewed them with the program, we actually reviewed them with headquarters to get their blessing on that thing. So this was it was a period of very intense growth, and this was good for the people in mission control, even though we were short-staffed.
Thank you very much. Great comments, guys. Okay, now a question for pretty much anyone that wants to answer. The STS-1 countdown demonstration test was held less than a month before flight. And although the test went well, immediately after the test, 3 technicians went into the aft compartment of Columbia. And due to, there was nitrogen there due to the nitrogen purge of the aft compartment. This nitrogen overwhelmed the 3 technicians, and they died because of this. How did this tragedy affect you so near to STS-1?
Stokes, if I may, I'd like to address that. As you said, John Young and I had just completed the countdown demonstration test, and it had gone very well, and we'd gone back to the crew quarters feeling pretty good about the test, thinking maybe we are getting close to flight. And then we got a call about the accident. Turns out there were 6 people cleared into the aft compartment, which was still being purged. It was due to a deviation they were running to the procedure, and miscommunication at the Cape. And these guys were cleared in. And as you said, it was a pure nitrogen atmosphere, and that's deadly. Thank goodness the sixth guy, when he was climbing in, noticed that everybody was passed out or unconscious and called for help. And as it turned out, John Bordstadt was dead on the scene. Forrest Cole died when they got him to the hospital. Nick Mullen died a couple of years later due to complications from it. It was a sad accident, proving that spaceflight can be dangerous not only to the flight crews, but the people that work around the spacecraft.
Okay, thanks, Crippen. Yeah, that was a very, very tough time, I remember. Okay, Dick Truly, you were instrumental in developing the abort concept called the transatlantic abort. How did that come about?
Stokes, first of all, I have to give a little bit of background. Joe and I, after ALT was over, got assigned backup to John and Crippen for STS-1. And when we started preparations with the flight control team for Ascent with Neil and his team, I had been working the computer software for ALT, and Crippen had been working for the first flight. And then I came over to help Crippen. And one of the problems was the possibility of one or two engines quitting during the ascent. And there was, from liftoff to a few minutes in the flight, we had this crazy abort mode called RTLS, return to landing site. And thank God nobody ever had to demonstrate it, but it was in place. But the second we could not get back to the Cape and land for several minutes until we could sustain engine loss, we were stuck. We couldn't get back to the flight, and we didn't have enough energy to enter orbit. And so Joe Engel and I, not an integrated sim, started talking about how do we solve this problem? And the STS-1 trajectory crossed Rota Naval Air Station that had a runway. And so I had this wild and crazy idea that maybe we could figure out how to make the backup flight system monitor the entry profile to Rota. And so I configured one of the computers to show the entry to Rota during the ascent. And sure enough, I noticed that the backup flight system, which was totally different than the primary, would track the shuttle on the backup flight system. And I talked to Joe and said, what if we shut down the good engines at the correct point and and separate from the tank and turn around the shuttle to entry attitude? I wondered whether we could drift into the cone, the entry cone that was being monitored by the backup flight system, and we would immediately being on entry into Rota. And so we got the simulator crew to let us play around with several runs, and we, Joe and I, killed ourselves many times, but once we were successful, and we changed from a Ascent category into a backup flight system monitored in the middle of the corridor for entry. And so we engaged the backup system and landed at Rota. And that was all I had to do with it, but and I would love to hear Neil's comments on this thing. But at that point, we turned it over to the system, and we ended up with coverage from liftoff through RTLS, and when we could land across the Atlantic until we got to enough energy to either have once around orbit abort to land at Edwards, and then later actually get to orbit. It was a great success, and that's the story.
Great story. I mean, it was amazing you came up with that concept.
Hey, Dick, Stokes.
Go ahead.
Before Neil may want to say something about looking at the abort modes, and I wasn't the Ascent flight director, I think it resulted by having the TAL capability, it really narrowed the window of the return to landing site option. So that really improved staying away or reducing the risk of having to try an RTLS.
Yeah, that is true. Somewhat, we did cut the end of the RTLS thing off by doing that. And of course, as Dick has appropriately said, the real problem with trying to get a TAL abort was the fact there was no software to get you there, like there was to, the crew actually had a switch. They could go abort to orbit, and the software guidance systems would execute that. The other thing that the TAL business helped with is, we used to practice a lot single engines out, and loss of a single engine, the TAL picked up between RTLS and abort to orbit. And what it also did was it allowed you under some circumstances to get the rota on one engine, in other words, two engines out. And of course, once they had sorted this thing out as that we were going to have a runway in Spain, and as the program evolved, of course, those runways were all over the place. They weren't all in Spain; they were in England. I don't know where they were, but they used a lot of other ones besides just the one we used for STS-1. Some of that depends on the inclination you're going to, and so on and so forth. However, that whole idea got fed back into the flight techniques business, and it wasn't long until we basically had a TAL abort, and to go along with the other calls, negative seats when we couldn't use the ejection seats anymore, and negative RTLS, which we didn't want to turn around anymore when we had a capability of for single engine out getting the rota. So it was a very important piece of work that ended up being put into the procedures and the process and the way you fly the ship to be able to pull it off.
And it lasted for every shuttle flight afterwards too.
Yes, sir.
Okay, so now we can get into the flight itself. So question for you, Neil and Cripp. During the first launch attempt, which was April 10th, 1981, the backup flight computer did not transition along with the primary computer software from the pre-launch mode to the flight mode. So this caused the first launch attempt to be scrubbed. What was the result of that event?
Well, I don't know. Cripp got out of the cockpit and I went home.
That was pretty much it. we had brought up the backup flight control prior to liftoff in simulations and in the sail many, many times. Mm-hmm. And nobody had ever seen this. To the best of my knowledge, if they did, they didn't report it. When I brought up the BFS, it couldn't communicate with the primary system. So that was naturally a no-go, and nobody knew why. Because it turned out there was a very small window. When I turned it on, I think it was about 40 milliseconds. If I turned it on during that period, it wouldn't communicate. So the answer to it turned out to be what everybody knows about electronics, cycle power. And that's really all we had to do. But no, we had to understand it, and some smart people figured that out quickly. So we were able to launch a day after that on the 12th.
The other thing I thought about, Cripp, when that happened was call Jack Garman.
That's right.
Thorson, one or the other. They got to know the answer to this.
Yeah.
But we didn't fit. Of course, no one figured it out in real time. We, as you said, and even if we had, I'm not sure if we would have gotten it to hook up. I don't know if we'd have trusted it.
But it was
we had to understand it before we'd be ready to launch.
Yep.
Okay, thanks. But so it was a quick turnaround. So you did eventually launch 2 days later on April 12th. And so Neil, you were the Ascent flight director on shift during the Ascent. And during the initial part of the Ascent, Columbia's trajectory was lofted. It was higher than it was expected to be. So it flattened out after separation of the solid rocket boosters. But what were you thinking during that period when it was lofted?
Well, a couple of things. One is that in first stage, you're basically looking at a velocity and flight path angle target with it's not anywhere near as sophisticated a closed loop guidance system that you have when you're finally going. And my thought was, number one, first thought was tell Cripp and John, which we did, I believe. I don't remember, but I'm pretty sure we did, that he was going to be a little high and fast. And, we weren't near any limit lines or anything else. If you're going to have a problem, you'd much rather have it lofting than being depressed. And frankly, my crude thought at the time was, well, we probably missed the aerodynamics. I mean, if we didn't have the drag right, if it's less than we thought, the vehicle go a little farther with a little more juice. And of course, it turned out that wasn't the problem. I believe the problem was that we kind of underestimated what we were going to get out of the SRBs at sea level. And when we got to staging, the guidance very quickly realized that they were lofted, that the vehicle was lofted, and it just homed right in on the MECO targets. And during the flight, it was not something it was something we hadn't seen, but it wasn't something that bothered me. I don't think about Jay Green was the flight dynamics officer with me, and he said it a couple of times. We're still lofting flight, and we kind of said, well, let's get staged and we'll see where we go. So it was not a crisis of any sort. I don't know how Cripp saw it in the cockpit. I'm sure he saw it.
We did, as you said, you gave Dan Brandenstein, told him to tell us that we're lofting, which we could see. We have a trajectory display on one of our CRTs that had the planned trajectory, and it was obvious we were going above it. But like you said, I figured, well, higher is better than lower, and so we weren't really worried about
it. Okay, thank you. And so, like you guys said, Ascent settled down, and you got onto orbit, Cripp. So one of the first things you do once you achieved orbit was to open the payload bay doors. So what did you see when you opened those doors?
Well, first I saw that the doors operated like we wanted them to, which was a very important point. But then I could see back on the OMS pod, the orbital maneuvering system pods, that there was some tile missing. I pointed it out to John and taped some video of it so I could send it down to the ground when we got another pass. And John and I both knew that they had developed a pull system for all the critical tile, where they had a plunger-like device attached to the tile, pull on it a certain amount, and make sure that it was properly adhered to it. They didn't do that back on the OMS tiles because they weren't flight critical. They were there for reusability primarily. So I know that there was a lot of consternation about it, but I don't think John or I were that worried about it. Plus, if there was something missing on the bottom, we couldn't do anything about it anyhow.
Stokes, I would comment that when we saw the video from Crippen, you know, there was an uh-oh moment. But to be quite honest, the flight team in the control center, thermal protection, that's an anomaly you don't simulate. And the real assessment of how if it was a problem or not a problem or whatever was going to be done outside of the flight team by Rockwell and E&D, engineering organization at JSC. And so, you know, I did think in my mind when we opened the doors and there it was, I kind of went, uh-oh, but then, you know, you work on problems that you can work on. And that was not one that we in the flight team could analyze. And so obviously the offline folks in the MER and in the span room and back in Downey and building 16 and wherever did the analysis that said, well, those are not critical. And so that's, I wouldn't say it was a non-event, but it certainly wasn't, good Lord, we're going to need to get out of orbit or anything at this point.
Yeah, I might add to what Neil said. Either we came on right at about the same time he was in and off. But anyway, the first time we saw it in the control center, my uh-oh moment was the thought, oh crap. And the first thing you think about is the tile on the bottom. Are they going to be okay? And then once you think about that a little bit, it's a passive system. There's nothing you can do. So impact of the flight control team, and I think others were accepting the fact that we might have a real problem and we might lose a crew. That could really be serious business if we had any damage at all on the bottom. So I think it didn't impact us on the team as far as the activity that we provided later, but it was obviously very critical to get a new baseline on the bottom of the spacecraft, on the bottom of the orbiter, because we knew what our baseline was at launch, but that baseline may have changed and we needed to know that. It was critical because if the baseline had changed, then we needed to know, and if we landed, we needed to know if there was any change. We knew what it was changing from, and it may not have been changing from the launch for liftoff time, but later in flight. So to me, it was obviously very critical that we get some kind of data from that. And of course, Gene picked up the ball at that point and started working it. There's, like I said earlier, nothing we could do. It was passive. So we just needed to try to get data for post-flight work, if at all possible.
Folks, let me pick up on the discussions between Neil and Chuck. As I indicated, I covered the CCB, the orbiter CCB, and about the summer before launch, a discussion from Kennedy that started a real interesting series of events Kennedy indicated that they were going to, and they would always do a walk down to the beach to see if any elements of the debris or tiles or anything had come off the orbiter. Well, that started a series of discussions between Rockwell, the Cape, and JSC on the installation of the tiles. And the tiles basically have a lumen structure that basically use RTV on the structure to adhere the SIP, which then some more RTV to make the tile adhere. So it's basically a very complex process of many thousand tiles in there. So I was asked to pull together a team to provide evaluation during the course of a mission based on a video material from launch, 70mm film DFI telemetry, which was scattered at various locations on the underside of the orbiter, optic data, and material information we'd get from some DoD assets. We developed a map of the underside of the tile, all of the maps, all the tile locations, and the locations of the LRVs, LRUs, DFI instrumentation that was down there, and what we called the systems nodes. So we were prepared if a problem occurred as a result of information coming in from one of the assets to do this. Prior to this, they had gone through a TPS repair exercise, and they scrubbed that as risky and not particularly beneficial. They also looked at changes to the entry profiles, and that was only a modest. And they felt both of those would be distracting to the preparation from STS-1. So we had a pretty good set of capabilities we could look at. And one of the ones that was used extensively were the various DFI locations down there, which would indicate certain areas of the tiles were certainly intact. Concern was that they would basically zipper off. One would come loose and pull an entire strip off. And to my knowledge, they didn't have any problems there. And when it finally landed, they had a lot of damage to the surface of the tiles they believe occurred in launch and landing that had to be repaired. And I think only about 200 tiles were replaced in the turnaround for STS-2.
How many of the tile, Gene, how many of the tile were actually on the bottom in the critical areas? Were there any lost there?
No.
Okay, thanks.
There was some with some pretty good scarring down there. In fact, I think that was one of the first things John Young, when he went underneath there to take a look at the inside of the structure, I think he pointed out a couple that had some pretty severe surface damage.
You know, the funny thing about that, about the post-flight part of this is that it's not funny at all. And in fact, I didn't really find out about much of this until I think it was after, may have been even after Dick flew. We had a couple of places where one was the starboard wheel well, where either the gap and filler,
yes,
when these tiles are put in, they have to have a kind of a filler in between each one. And I don't know the technical details, but we did get a lot of heating inside that starboard wheel. I think it was the starboard wheel well. And in fact, it actually damaged some of the structure of the wheel strut, which is, if you think about it, it's pretty scary. Another place that we had the same kind of a problem was the ET door. And when the big umbilicals disconnect, when the ET goes away, there's a door that has to shut. It's on the bottom of the orbiter. And we didn't know about, of course, we didn't know about any of this in the flight, but we found out about it later, and a very discomforting thought. But of course, they fixed that before we went to STS-2.
Yeah, I think there was also some damage to the left elevon and part of the body flap. Same nature, though.
Yeah. Well, we ought to, yeah, sometime in this discussion, we ought to talk about the body flap thing, because, boy, there was a problem in the body flap at launch that none of us knew about. And it was Again, something I didn't find out about. I don't think I heard about this till, I don't know, I wasn't even a flight director anymore, maybe when I heard about it, but the body flap got deflected very badly by the SRB overpressure in Ascent. In fact, it got deflected far enough that theoretically it should have broken the hydraulic system. You know, the hydraulic system's commanding it to trail, and the overpressure forced it into a position that it didn't want to be. Again, we didn't know anything about that in the flight. I don't know.
I'm with you. I don't remember hearing anything about it, you know, months later.
Right. I didn't either. When did you find out about the body flap? Cripp, wasn't that quite a bit after flying?
It was a long while after.
STS-2, so the system knew about it.
Yeah, but I don't think I heard about it until much later.
But they increased the water deluge or something to try and
what they did was put in what I call water logs. There are some troughs underneath the SRBs that they did for Dick's flight to absorb that energy. You know, we also bent a strut that was holding up in the forward RCS that was holding one of the tanks.
Yeah. It didn't break, but it did damage it, didn't it?
Right, that's correct. I learned about that one fairly shortly after the flight, but not the body flap.
Well, to me, it goes back to one of my early worries, and that was the configuration of this thing sitting on the pad and how difficult it had to be to try to calculate all the loading and the pressure, overpressure. I don't know how they did it. We got close enough, got it done. I guess it's one of those cases where you just trust the design right off the start of the program, and it worked for us.
Why you do testing, Chuck?
Well, I know, but we did a lot of testing, but not in an unmanned, not the old way, the unmanned way. Right. We got engine testing, but you didn't get any tile testing other than just, you didn't get a good TPS test.
Yeah, I agree with you. I think though that with computational fluid dynamics and a lot of other things that the structures guys did, I think we hit the Ascent arrow pretty close. We did not hit the entry arrow as close as we would have liked, I think, but the Ascent arrow models that were used to prove that how far we needed to pull the throttles back on the mains and at max Q and that kind of stuff. I think that the program had an amazingly valid set of data.
I concur. It did.
Well, thank you. And so this question about tiles on the bottom, were any of them lost, that became one of the big questions in the press. And so Gene, and to some degree, Neil and Chuck, you know, y'all, after a flight control team shift, you had change of shift press conferences. And Gene, I think you were the one that mainly got the questions from the press about how were you going to determine if there were missing tiles on the bottom of the orbiter. So how did you handle those questions?
It was easy for me. I ducked, and I knew Gene would have to pick it up.
It was easy for me too. All I said, 3 words: national technical means.
Yeah. Boy, when those questions started coming up, I said, uh-oh, I'm not going to get into that. Gene will have to handle it.
Your turn, Gene.
Gene, I think you're
we punted Gene.
Gene, you're on mute. Hey, Gene, we're not hearing you. Gene, you're muted.
Yeah, okay, I'm muted here.
Actually, on purpose, Gene.
Well, actually, they'd ask Neil a question and I'd just say, that's classified. But what happened was that the following morning after the first press conference we had with Neil, John Yardley did a Good Morning America talk that sort of opened up the entire discussion again. So from then on, we could punt to Yardley.
Okay, great. Thank you. Yeah, because as Gene said, a lot of this was classified and it remains classified. So, to anyone, we got used to in the shuttle program having communication all the time because but STS-1 was in the days before the first tracking and data relay communication satellite was used. That was on STS-9. So during STS-1, Columbia was in touch with the ground barely 25% of the time. So what did the crew and the flight controllers do during these periods of loss of signal?
It kind of depended upon what the activity was, whether or not you're working problems or not working problems. But and I can't speak for the others, but if you had a quiet pass, nothing much was going on, first thing I would do is take my headset off, pick up my cup of cold coffee and go take a leak, and then rinse out my coffee cup, go back by the coffee pot, get a fresh cup of coffee, come back and sit down, and probably nothing much going on, look at the flight plan, see what's coming up. Now, if you had a problem going, you could delay most of that activity, and you just work the problem with either one or more of your flight controllers during the LOS period.
I'll comment maybe, it was actually kind of nice on board. We only had 2 of us up there and we were very busy. And so if the ground was talking to you, you couldn't be doing whatever you were doing. So we took advantage of that. Those initial flights, we didn't have the wireless mics, the headsets that they later got. So we had to be connected to with wires to the console so we could listen to the ground. And so, it was nice to be able to just take the headset off knowing when they were going to come up next.
Yeah. To go back to the coverage, as Stokes mentioned, the best coverage, of course, is the initial launch in the first 3 or 4 revs, because you've got the United States, multiple sites, you've got Hawaii, Canaries, down to Australia, so you got good coverage. But as you get into, the 5th, 6th orbit, you begin to lose that. And pretty soon, and normally during a crew sleep period, and it's kind of planned that way, you're down to 1 or 2 sites in a 90-minute rev. So you really, if you had anything happen then, you really had to be ready to go to discuss problems with the crew. And you only had probably about 6 minutes of coverage over 1 site. But we had learned early on how to handle some rules. The Capcom was the only one that spoke to the crew. We played that game from the very beginning. You needed only 1 person communicating to the crew and working that. And it was normally one of the astronauts. The flight director did have to approve of any traffic we sent to the crew if it was direction or an interpretation of something on the vehicle. Other than that, it was pretty free to visit if there's a chance to visit, which there was some cases. You might get somebody asking you, I'm looking at this, I'm looking at, and the Capcom might chat with them a little bit. So with the discipline, the short passes could be worked. We worked them in other programs. We worked them on these. If you run into a problem, you just have to be disciplined enough to get as much done as you can during that 6 minutes. And we simulated those, and the Capcom was well aware of watch the clock. And if we got into a situation we weren't going to get everything up that we needed to before LOS, then we'd we knew about where to cut it off. We didn't want to have LOS and have halfway through telling the crew to do something or listening to the crew and it break up. So we learned to work with it, I think, pretty well. So it was a rare exception that anybody other than the Capcom spoke to the crew. There were some exceptions. For example, we might get a request from the president, they want to talk to the crew. Well, I wasn't about to say, well, we have this rule that we can only they can only talk, no way. So everybody's got a boss. So we work those directly, but generally speaking, it was well-disciplined air-ground communications at all times. And that's, I can't add much more to that. We just got, it's something to live with. Skylab was a good example. Lord, we went 8 months and we had nothing but that network. And we did have a teleprinter that we could use to get stuff up, but you'd run into those passes with only 1 or 2 acquisitions during the period. And it was pretty, it wasn't difficult, but it took discipline. That's about all I can say about that. Be ready.
Okay. Anyone else? Okay, well, one of the other major malfunctions on orbit was with the development flight instrumentation recorder. Gene had mentioned how it was used to record a lot of important flight parameters that would be used for post-mission analysis of Columbia's performance. Well, during the mission, the recorder malfunctioned, and I think it was pretty much recording all the time, and so it was going to run out of tape. And so Crippen had to pull the circuit breaker to remove power from the DFI recorder. So Crippen, could you talk about that? I mean, you tried to replace it, and then what did you do about re-entry for it?
It was frustrating time, really, yeah, because we did play with the circuit breaker and the DFI recorder for quite a bit. And then finally they did ask if there was possibility we could switch it out with one that wasn't as critical. And to do that, they had built a special cabinet down on the middeck that had the recorder in it. And I'd been a big proponent of in-flight maintenance. We had a nice toolkit on board, and I thought this was a good time to show what we could do. So I went down to remove the fasteners to get into the recorder, and I could not get one of them loose. Finally called John to ask him whether he could. He tried, he couldn't either. In retrospect, we found out after we got down on the ground, the tech that put that cabinet together had used a substance called Loctite. There was no way to get those fasteners out unless you took a drill to it.
I've used that, Crippen. You didn't have a chance.
No. So we ended up flying, and my recollection was that it was an instrumentation problem, and it was working right, but it's been a long ago. I don't remember for sure, and I think they got the data they needed.
I don't remember it at all. I called Lee Briscoe because he was our INCO during the flight, and by the way, he wanted me to tell you specifically hello.
Give me my regards.
He couldn't remember anything either because the flight control didn't have anything to do with the DFI recorders equipment. That was strictly engineering post-flight. I never did know if they got the data. Well, I would hope they got it because that's kind of critical to get it. And I know that's why we pushed you a little bit to try to get into the breaker. And I don't still understand what the actual problem was, but I'm with you. I hope they got the data.
Okay, so after 54 hours of being on orbit, Crippen, you and John fired the OMS engines to start re-entering the Earth's atmosphere. And during entry, you saw some unexpected flight control responses during a hypersonic flight, so some unusual things that weren't expected. What were you thinking at that time?
Well, we talked earlier, you can do so much with simulation on the ground, trying to simulate hypersonic flight. So we went into entry knowing that there were a lot of unknowns with it. And we did see that during that first role reversal, we got more yaw than we anticipated, but it didn't look like it was going to cause us to lose control. And then the body flap also went down further than it was supposed to. But I don't think John or I worried about it very much. I mentioned it to John. He kind of rogered it, but I don't think he didn't indicate it that it was worrying him.
Okay. And there were several minutes during the Columbus reentry into the atmosphere where the superheated plasma surrounding the orbiter prevented radio contact with the ground. Now, although this was a known and expected condition, what was the environment like in Mission Control during this entry blackout?
Very quiet.
Quiet. That's what I wrote. Very quiet. A little bit of chatter from the chase planes, but that was about it.
You know, I would make a comment here about Don Putty. When I got the Ascent assignment and we started trying to get the team put together and everything, I kind of made a rule that I didn't want anybody on the console that didn't have a reason to be there, i.e. an assigned position. And I did maintain that. Of course, as I said earlier, I couldn't keep Max Faget out of the room, but I kept everybody else out of the room who might have wanted to come in and plug in and watch Ascent. Well, I think Dick and Joe were there, but on large, we just kept it to the team, to each individual operator at their console. And Don Putty did something that, in retrospect, I didn't really appreciate it at the time, but since I've come to really appreciate it. And that's the fact that he let operators from other teams come in there and plug into the console, including Chuck and I, who were plugged in at the flight director console so that we could not participate actively because we were staying out of the way, of course, but it could be in the control center during the entry of STS-1. And thank goodness Don did that, because it was a hell of a gesture, and it would have detracted some from our participation in the flight if we hadn't seen that vehicle come to wheel stop with our own eyeballs.
Yeah, you're right, Neil.
All Putty did that.
I asked Don if it was okay if I could sit on the ledge behind him, plug in for the entry, and I sure appreciated that, because that was neat to be there when they came in and we got a successful landing.
Yeah, and back on your question, Stokes, that time period where the crew is in blackout, it's you could hear a pin drop in the control center.
I bet.
Hey Stokes, I was plugged in. I was in the Mocher and plugged in to the Capcom's console, and otherwise keeping my mouth shut. But I was thinking how little the wind tunnel data and the little model we have had while Crippen and John were really re-entering, and I was nervous.
Yeah, we had nowhere near the aero data for entry that we had in Ascent. Not even close. Couldn't do the hypersonic part.
Right. Well, Cripp, during entry, what were your, so you were blacked out for several minutes, but then you reacquired radio contact with Houston at about 190,000 feet in Mach 10. And then Chase 1, who was flown by John McBride, pulled up to your starboard at about 30,000 feet. So what were your feelings at both of those events?
Well, I remember when the coast of California came into sight and we flew over the coastline, and we could see all the way across the Sierra Mountains to Edwards Air Force Base and Dry Lake Bed. One time, I think I made some comment like, what a way to come to California.
Yeah.
John did a beautiful job bringing the vehicle in. We went subsonic, and as you say, McBride and a T-38 who was going to fly chase, and we had a photographer with him. He'd worked very hard on doing that. That's quite a rendezvous. He hit us just about the time we went subsonic, right over the base. He'd worked with the radar there at Edwards to be able to do that, and came aboard, did a great job, and he could check out the tiles to make sure that we could differentiate anything that was there coming in for a landing, but other than the debris might come off the lake bed. So it was a fantastic job. John did a super job of greasing it on the lake bed out there, and let it come to a wheel stop. It didn't break very much.
So what was it like after wheel stop?
Pretty big celebration.
I'll tell you, there was a celebration on board too, primarily by John. I was still busy working with Joe Allen, the Capcom, on getting the vehicle configured, and John unstrapped as soon as he could, and he was bouncing between the middeck and the flight deck several times. He anxious to get out, but of course they had to check for any noxious fumes out there. But John was, as you saw on the video when he came out the hatch, he was about as excited as I've ever seen John Young. It was a rewarding moment for both of us that the thing worked. We worked on it for a long time, and the mission came off probably better than any of us thought it could.
Hey, Cripp, I think John pulled rank on you. He was underneath the orbiter, and you were still up there trying to get the orbiter shut down.
I was still throwing switches.
So I think he pulled rank on you right there. You know, what I remember, my memory was, and it's the one that I'll never lose, was he came out, after he egressed, he came down that ladder ramp, he went right past George Abbey, never even looked at him, went right up underneath the orbiter. And what I remember seeing was he was giving it that fist punch, you know, yes. I could, if I could hear him, he was probably saying, yes, yes, yes. I'll never, that was the moment that I won't forget. And when I saw that, I thought that was kind of the icing on the cake, and I said, we got a program.
I would also make a comment about the control center. We did have a bit of a celebration. The problem with the celebration in the control center for shuttle versus at wheel stop versus the splashdown in the Mercury, Gemini, and Apollo is that the control center still had a lot of work to do. Putty's team and Cripp said it, through Joe Allen, and Cripp was still in the orbiter. Well, all of those, that safing and everything is all monitored and orchestrated by the control center. So we all hollered and hooped for about 10 seconds or 30 seconds or something, and then had to shut up and let Putty and his guys do their business. One thing I do remember from that little celebration is when things kind of quieted down and Putty got back to work, getting the rest of Putty and Cripp getting the rest of the switches set up and so on. There was a loud knock on the window of the VIP room, and we were all standing right there by the flight director console. Just about everybody was on their feet, and it was Chris Kraft. And Kraft had a 8.5 by 11 piece of paper, and he had written on it, "We just got infinitely smarter." And he was holding it up against the window so we could read it. Never more true words were spoken, because we did get infinitely smart.
Yes, you did, and NASA did too. So Cripp and Dick, how did your flights on the shuttle compare to training you received on the shuttle mission simulator and the shuttle training aircraft?
I'll go first, I guess. Dick, you go ahead.
No.
Well, we came back and we made a few minor mods to the motion-based simulator to try to get it to more, shape more like the shuttle did, and some more noise, that kind of thing. But overall, the simulators were excellent, and the shuttle training airplane was outstanding. Those vehicles, the STAs, made it possible for all the nice touchdowns that have occurred throughout all the flights on the space shuttle. So it was a lifesaver as far as training is concerned. Dick?
Well, I would agree with Cripp. The shuttle mission simulator was perfect as to throwing switches in the gauges. It was fantastic. Landing in the simulator was kind of pinball, and but the STA was an airplane, and it was between the shuttle mission simulator and the STA airplane. Landing the shuttle was a piece of cake. I thought the shuttle was easier to land than the STA. And, so we were prepared.
I'd add something to that, not to the airplane part of it, but we, at the beginning of this little conversation we've had, we were talking about that big gap between when we first started simulating and when we finally launched. And that gap was, that time was approximately 3 years, not quite. And I know that Chuck and Bud and I and both sets of flight crews, the STS-1 and 2 guys, we must have we ran hundreds and hundreds of simulations. I think I'm going to pick a number. I ran 500 launch abort simulations. And I think maybe we got to orbit on 2 of them. All the rest of them, we did something crazy and ended up in an abort mode somewhere. And of course, the flight was, from my standpoint, I mean, we've mentioned a few things like the lofting and the tiles and whatever, but the flight was almost perfect. We had practiced so much and felt like we were capable of handling just about anything that you could cook up that could break on that vehicle. And of course, then nothing broke. And pretty darn remarkable, if you ask me, for a first vehicle on the first flight. The software on board worked great. Software in the control center worked great. It all just really was a pleasure to do.
I can vouch for what Neil said about the number of sims he ran. I didn't get an exact count, but he took about 80% of the time of the simulator doing Ascent sims. Don probably got 15 or maybe 20. I got maybe a dozen orbit simulations in the whole damn 2 years. You talk about hogging the simulator.
Well,
now that's true. I'm not pulling you.
I don't know.
Isn't it, Neil? Because
But I was thankful for every one of them.
Hey, I was glad you got them. That's probably the most critical part of the flight. And you needed a lot of training because there's no turning around on that asset. You got to keep going one way or the other.
Yeah. Well, we pretty much sat there and watched it go.
Yeah.
Well, you learned well at the simulator. So you successfully landed, and I remember Clear Lake City, where NASA is located. It was wild that night with post-landing parties. So here's a good chance for any of you guys to have any good stories about those post-landing parties.
As usual, the outpost was packed.
Yes, we all went to the
and people standing outside.
You know, it's interesting. I don't know what Chuck's, of course, Crippen and John were still at Edwards and hadn't made it back to Houston till the next day. But I frankly don't remember any. We certainly went out and had a beer and patted each other on the back and so on. It seemed to me that we were more subdued after STS-1 than we were after any one of the Apollo or the Skylab ones, after those kind of splashdown things, which seemed to go on for days. It certainly went on for 12 hours after the crew was back on the ground or back in the ocean or on a ship. And so I don't, maybe Chuck remembers or Gino, but I don't think we did a hell of a lot of celebrating. Well, I know we
didn't. I don't remember. I'm with you. I remember only going to the outpost and having a couple of beers. And I don't much beyond that. I don't remember any I don't remember a lot of partying. If there were a lot of parties, I wasn't going.
When things settled down and people began to realize outside of NASA what an incredible feat we just pulled off, there was a lot of hoopla that went on that included the flight control teams, or some of us anyway, and I didn't remember that kind of a fuss being made even after we pulled off something like one of the Apollo flights. Of course, the crews had a ticker tape parade and so on and so forth. But in the case of the shuttle, the President of the United States invited us to the White House, all of us, the crew, the flight directors and the program people. And there was a fair amount of what I'd call formal celebration that went down after STS-1 that was not only a pleasant surprise, but kind of hammered home the significance of what we pulled off.
Yeah, I remember the trip up to Washington, D.C., Neil, the three of us and our wives. And I remember we got invited to the Rose Garden to meet President Reagan, and the wives weren't invited. So as we entered the White House grounds in the van, we looked down and our wives were in line to get a tour of the White House.
I wasn't going to mention that, but okay.
Well, here's a question for Dick Truly. Dick, as pilot on STS-2, how did it feel to inherit the world's first used spacecraft?
Well, Joe and I had a joke that went like, would you buy a used car from John and Crippen? But all joking aside, during this conversation, I realized that none of the problems that Crippen and John had on the first flight, Joe and I had on the second flight. And that is an amazing comment to make in compliment to the engineering built into the spacecraft and the flight control organization. We had a lot of problems. Foremost, probably when I had to shut down a fuel cell and we cut the flight in half, but the shuttle demonstrated on the first flight that it was a fantastic machine and system. But Joe and I were happy to take the keys from John and Crippen and fly later that year.
That's great. Thanks. Okay, so the last question I have before we get to the other questions people ask, after a successful flight of STS-1, and this is for anyone, what were your thoughts for the future of the shuttle and the manned space program?
Got to get ready for STS-2. I mean, you know, there's no rest for the wicked. We leapt right into trying to get tuned up with we got some simulations with Dick and Joe, but we went right at it, right? As soon as we got reorganized, we might have taken a couple, 3 days off. And in terms of the long range look, in my own opinion would be that this is going to show some of my bias here. I felt very uncomfortable, and I got even more uncomfortable after I left the flight director office about the insistence that we had a fully operational system here after only flying it 4 times. I always felt that thought process was more politically motivated than anything else, and it did not correctly acknowledge the sophistication and complexity of the piece of hardware we had and were expecting to fly over and over. And however, that's the way it went. I mean, we declared the shuttle, quote, operational after STS-4, and of course, back then, despite the fact we had such a difficult time getting Columbia ready for the first flight, you know, people were still running around talking about flying 20 or 30 or 40 times a year, which I think us at least in the operations side of the business felt it was nonsense. I didn't see how that could come about, and of course it didn't. But all in all, when you look back over all the flights, and of course we had a couple of tough ones. When you look back over the whole program, as Dick said, it was just a hell of an engineering fleet, engineering miracle, not a miracle, but feat. That plane was, and all the rest of it, not only the plane, but the rest of the piece parts too. And it served us really well. We wouldn't have a space station without it. And we wouldn't have gotten all the experience that we got learning how to, as Dick said, get the keys from one crew to the next crew to the next crew. And, you know, refurbishing the SRBs and reusing the engines and reusing the biggest part of the whole system in the orbiter. And that, of course, is kind of the mantra in today's spaceflight: reuse the piece parts.
You know, Neil, I got to agree with you. On the fourth flight, we were still in what they called operational flight test, and we were flying a classified payload. And we're still in the test phase. That was political.
You know, Stokes, from my standpoint, I had 2 stints in flight test. Once at McDonnell before I joined my pilot training class, and another one for 30 months out at Holloman on the B-52. And my first flight test boss was a guy by the name of Harry Carroll. He was a World War II aviator. He flew with the 15th Air Force and was one of the Pulaski Raiders. And everybody is familiar with the history of the raids on the oil facilities down in that area that recognized that the survival rate was really a challenge. He then went to the 8th Air Force and flew in support of Berlin, etc. His lesson to his flight test engineers was treat every flight as if it was the first flight.
You bet.
And that is basically what he called the flight test mentality. And I critiqued the Columbia accident report and address that issue as part of the challenge, I think, to the operators of the future. Stokes, you're quiet. You're muted. I see you talking.
Oh, okay, sorry about that. So let me get to some questions from the audience today. Here's one from Steve Lobby, who used to be in JSC Engineering. To anyone, what would you say was the key to success for STS-1? And what would you, in hindsight, have done different?
Stokes, I think it was the whole thing, the team, the people, the contractors and the NASA folks working their tails off to make it a success. And I know personally, that's what gave me a lot of confidence to go climb in the vehicle for the first flight. I walked and talked with a lot of people involved, from the people that twisted the boats to the people that ran the program. And I think that was the thing that made STS-1 a success.
I agree with Crippen. It's the team. It's not just the people who are flying or the people in the control. It's everybody. And you know, when we went through that period from 1978 to 1981, the program was suffering catastrophic problems with tiles and engines, and they persevered. You know, I would say that the development and test personnel that finally got engine blades to not crack and finally got tiles to stay on, you got to hand it to them, because time and time again, they thought they had a fix and it wasn't. They had to do it again. And sure enough, they just month after month after month persevered. So the perseverance of the engineering and development teams that put that ship together, it would certainly get my vote.
Well, one of those for sure was Tom Mosier and his guys. They were the ones up under the gun constantly, and they came up with a solution. A lot of hard work, a lot of testing, never gave up.
You know, I think Tom is listening today.
Attaboys to Tom and his guys.
Okay, here's a question from Michelle Brecky, and she's addresses to Gene Kranz. Michelle says, "I'm working in the industry and get pushback on doing things the way that we proved worked well during the shuttle. And she gets pushback simply because we did it on the shuttle. It's like throwing the baby out with the bathwater. How would you address that kind of pushback with the goal to win over the naysayers?"
That's a tough question, and I'd address that up to the top level management. You know, and I think the key to our success was that we had experienced leadership at the program headquarters level and at the institutional levels that trusted us to do the work and gave us their support when challenges occurred. I think the real key from Michelle, to answer Michelle, is to establish a flight test mentality at the very top level in the agency. I was about ready to talk about with Dick Truly when he talked about STS-2, and Neil's familiar with this, and shutting down the fuel cell and the leadership issues that we had beginning at the top levels. And these issues existed all the way through at least a good portion of my remaining career there. So I think the real issue is how do you find leadership at the level that basically is capable of listening to people, motivating the people, issuing the challenge, and then turning the limb loose and trusting them to execute. And I think there has to be a level of trust that is necessary as we move into the future.
Let me add it to that, Gene. Kraft, of course, the first flight director, defined flight operations as we did all of the programs from Mercury through the shuttle. He protected that flight director position many times. The bureaucracy was wanting in the management of the flights. And that he kept the bureaucracy out of our way as a leader in the control center, at least. And we could have easily lost it if we hadn't had the kind of leader we had in Kraft, for example, because he protected what he saw to be the right thing to do and how to form a flight operations and get it conducted. For example, you know, when we formed a flight operations, quote, team, as we've talked about, there were people from many different divisions, different directorates that had a person on that team. There was no line management in the way. When they joined that team, they belonged to the flight director, and that's the way they supported the flight director. They were there to support him, not the boss of the division or another branch chief or some bureaucrat. So that goes back to what Gene's saying. You got to have the right leaders, and in this case, it kept the bureaucracy out of our way to let us get a job done.
Well, you know, going back to the same thing, where do you find the equivalent of George Lowe? Where do you find the equivalent of Frank Borman? where do you find the equivalent of people at the top who will let George Lowe, Frank Borman, to build organizations? I think we built an organization that had a culture that that was one based on excellence. They set a standard, they established trust, and then they turned us loose to grow the next generation. We got to grow after generation after generation after generation, capable of safe and successful flight operations, doing what is best for the people who fly.
You know, one of the comments I would make about the sort of in the line of Michelle's naysayers. One of the things that we all enjoyed right from the start, and I'm talking about all the way back at Mercury, and then as we progressed on through the various stages of the programs, we benefited greatly from the fact that no one had ever done what we were doing. And there were very few metrics. In other words, a naysayer would have a really hard time coming in at that time in history and telling us that we ought to do X or we ought to do Y, because nobody had ever done X or Y. And we got the privilege in the 60s and 70s and even through the shuttle, we got the privilege of doing it, of original work, I guess is the way I would put it, because no one had ever done it before. And therefore, it was very hard to measure us. And I remember all the way back in Mercury and Gemini, when we were trying to build the control center and we made one mistake after another, and we just said, uh-oh, turn around and fix it and press on, and nobody shook a finger at you or said that was dumb or anything like that. And I think part of that has to do with the fact that we were in a space and time in history when we were doing things that no one had ever done. I mean, nobody ever flew a vehicle that looked like this crazy asymmetric thing. And so we didn't get a lot of naysayers. And or if we got them, would have a hard time laying a metric on us saying, you didn't do this. And I think the kids, the men and women that are doing this today, I don't envy them, because there are a lot of people think they know what they're doing.
Well, Neil, going back on that, you know, we need the kind of people like they came up and said, well, let's add an EVA to Gemini 4.
Yeah.
let's combine, we had a Gina failure, so let's combine Gemini 7, Gemini 6, and make it a Gemini 76. It's a question of coming up with ideas, sense of direction, and say, hey, go do it. And it's a willingness to step forward and challenge your people to accept part of the risk of doing the job.
Let me add to that, Gene. How about Apollo 8?
Well, that's probably the ultimate, at least for our generation, that is.
Yeah. That wasn't on the schedule. That was put in late, and we had the management to go fight for it, and they got it. We wouldn't have had it in Apollo 8.
Yeah. Okay, well, here's a question from Mike Rodriguez that's kind of related to what you guys have been talking about. NASA is relying more and more on commercial space companies with firm fixed price contracts to build, test, manage, and fly their own spacecraft. What advice can you give to the current NASA technical workforce that is slowly moving to a more oversight role and less of a detailed engineering role?
I don't know. Woe be to the person who's not a smart buyer. And the way you get to be a smart buyer is you know as much about what you're buying as the guy that's building it. would be my comment. So I would be, you know, in SpaceX, I have to say I admire them. You know, like when they first got going, people used to ask me, well, what do you think about this? And I'd say, well, you come back and talk to me after they've flown 25 or 30 times and you'll see where they are. Well, they've done it and they're progressing pretty well. But my suspect is, I wasn't there when this went down, but I think NASA, I don't think they could have done it on their own, SpaceX. I think they got a lot of help. And they got it, even though NASA was buying a ride instead of buying a spaceship, I think a lot of the smarts and knowledge and processes and procedures that NASA invented and perfected were provided to these commercial guys to help them along. And I think that's great. But I think you got to be a smart buyer. If you're the United States government, you better know what you're buying or you might not get what you think.
Okay, any other comments on that? Well, we're at 4:30 now, so 2 hours into it. So how about one last question? And this is a question from John Lawrence. He says, in 1961, NASA met President Kennedy's goal of a moon landing and return before the end of the decade. Do you imagine now in 2021, NASA could respond to that same challenge?
I don't think so. We had the best of the best as the early management, as Gene talked about and others have talked about. You know, the Space Task Group was the bedrock of the manned space program, starting with Mercury. I don't think you can find that kind of leadership, particularly in one place, like they did at Langley, ever again. I just don't think you could gather those people up again. There's too much bureaucracy. They were, frankly, they were given a challenge, unreal, so to speak. You know, go to the moon, come back in 10 years, and they were given the money to do it. That's another factor. But we had the best of the best that managed us from the get-go.
Yeah, you know, Chuck mentioned the money, Stokes, and the fact of the matter is, it's a lot more than the money. It's the political and national will to achieve something spectacular, like the moon landing or whatever. I think that I have no doubt that if given the money, eventually NASA would wrap its arm around it to the extent that great people would rise to the occasion and execute. I see the problem as we don't have a national will like we had then, which was another just terrific thing. You know, I mentioned how many times we made mistakes and we just bought our way out of them. And this day and age, you instead of buying your way out of them, you got a bunch of guys looking over your shoulder wanting to know how come you spent the money that way or whatever. I would say that what we need is to get the national will to, I frankly kind of hope that the Chinese press on with what they're up to, because that may be one of the few things that would drive this country to be able to achieve a goal like the person just commented on.
Stokes, from my standpoint, I was called up on the 50th anniversary to talk to the cruise committee to try and answer the question that's been asked. And it was reported in Aviation Week in an editorial called The Price of Awe. And the testimony I indicated leadership. We've talked a lot about leadership. We've talked about unity. There should be one space program. And when I say one space program, I was in the tail end, or let's say the beginning of ISS End of Freedom. And there were so many different voices that the administration was responding to. They had a group of scientists out in California who were influencing policy. They had the remnants of the Bush Space Council that were influencing policy. They had entrepreneurs that came in. NASA did not have a sense of what it wanted to build and why it wanted to build it and how it was going to do it and what it involved. I mean, they could never grasp, so they kept changing the baseline that we were working to. They headed up, they split the agency up, I won't say into antagonistic elements where we'd be competing against each other as a pulling part and pulling one direction. I think the key thing is there are too many voices. NASA has to get the strength where it understands what its objective and what its goal is. And listen to people, but the fact is, don't let them overly influence the direction you're taking. You can't continue to change direction. And that was the case all the way through the shuttle, the station program from the time it was conceived. And I think it was 73, all the way through 84, the first 10 years.
Yeah, but Gene, what's changed? It's the same thing over and over again. There's no clear objective or schedule. We had a clear mandate and a schedule to get it done by. And I don't see that anywhere in NASA.
Well, that's what's lacked. But basically, we had a Tom Paine up there. We had John Yarley. We had Dale Myers. We had people in there who had a focus upon an objective and a mission to accomplish.
Right. Oh, Cripp, you're muted.
Time out. I see
Time
Cripp.
out.
Okay.
Oh. Okay. Okay.
I think it's time for me to cut grass, gang.
Right.
2 hours is long enough.
2 hours. What a great 2 hours it was. I mean, what great stories, guys, about a very exciting time at NASA. So on behalf of the NASA Alumni League, I'd like to thank our panelists, 5 outstanding guys that were at the beginning of NASA. Thank you for participating in this fascinating event. I hope all you listeners enjoyed as much as I did. So now we'll sign off until next time.
Bye, gang.
See you guys.
Bye, gang.
Have a great evening, everyone. Okay. Hey,